Good afternoon. Welcome to the NPTEL course. This is the third week of the NPTEL course on Calculus for Economics, Commerce and Management. So, before we begin, just let us wait for a few more minutes to see if other students are also joining. We'll just begin in about a few minutes. We'll just wait for one more minute and then we will begin. Okay, so let us now begin. So, as you know, every week, every Saturday, we have these live problem solving sessions from 3 p.m. to 5 p.m., where we solve questions from the previous year's assignment problems and they will help you solve the problems in the current year as well as score well on the exams. So this week was about sequences and series and limits. So as you can see, the questions will also be based on that. So every week the questions are based on what is being taught in the lectures during that week. So let us start with the first question. Okay, some of you are asking that you have missed the previous session. So no worries, even if you have missed the previous session, there is a YouTube channel for this course. I'll put it up in the Zoom chat box. So in the YouTube channel, you can go and watch the videos from the previous sessions, the recordings from the previous sessions as well. So it's not an issue if you have missed any session. You can always go back and watch it once again. And this is also if sometimes some students face some network issues while logging into Zoom. So if Zoom is causing issues for you and if the audio or with the video is not clear, even then I would suggest that you go to the YouTube and watch the live stream. So this session will be live streamed on YouTube as well. So you can go ahead and watch it as a live stream or as a recorded video on YouTube. So that's not a problem. Okay, and also these notes will be uploaded in a folder, and the link to that folder has been shared with you. And it's the in that same folder the notes for each of the week will be uploaded. So I will not be sharing the link for each PDF as such, but it's the link for the folder has already been shared, and you can go ahead and look at the folder and look at the notes for each of the weeks. Okay, I think all these logistics are clear now. Yeah, if you have any queries, feel free to either put it up in the chat box or you can even unmute yourself and ask. Okay, so let us begin with the first question. Question number 1, it says let A belong to R. R is the set of real numbers. 0 is less than A less than 1, then limit n tending to infinity A to the power n is what we need to find out. The options are 0, 1, A and infinity. 4 options are there as usual. And just as always, I will launch a poll for all of you. You will see the poll in your Zoom meeting. And please answer and select the correct option in the Zoom poll itself. Do not put it up in the chat box or send personal messages to me. it's always best to select the option in the Zoom poll. So take about a few minutes to think about this question and try to answer it in the poll. Okay, let us now discuss the solution. So as mentioned earlier, this R denotes the set of real numbers. So this means the set of all real numbers. And in order to solve answer, we are given that that a lies between 0 and 1. So a is less than 1 and it is positive, that is greater than 0. So let us do this substitution. Let us say that b equals 1 over a. What this means that b will now be greater than 1. So this means that limit n tending to infinity of a to the power n is limit n tending to infinity of a is 1 over b, so 1 over b to the power n, because b is 1 over a, so a is 1 over b. So this is limit n tending to infinity 1 to the power n over b to the power n, and 1 to the power anything remains 1 itself. So this is simply limit n tending to infinity 1 over b to the power n. And since b is positive and it is greater than 1, b is larger than 1. So if you keep multiplying b with itself, a number which is greater than 1 with itself, it will keep becoming larger and larger. So for example, let's say 2 as a number. So 2, then 2 into 2 will be 4. Then you add multiply another 2, that will make it 8. You multiply another 2, that will make it 16, and so on and so forth, as you can clearly see. So if you keep on multiplying a number larger than 1 with itself, the number will keep on becoming bigger and bigger. And here we are multiplying with itself infinite times. So in the limit n tending to infinity, this denominator will become infinity. So, and 1 over a very large number will be a very small number. So, and 1 over infinity will be 0. So this limit is 0. And why? Because limit n tending to infinity of b to the power n will tend to infinity, and 1 over infinity will be 0. So that is the solution, which is option A. So for those of you who selected option A, very good, because you are getting a hang of limits. And for those of you who did not, I hope it is now clear to all of you. If there are any questions, please feel free to ask them before we proceed to the next question. Okay, it seems it is all clear. Now we can proceed to the next question. So again, similar questions. We have a whole bunch of questions on limits and different limits under different conditions. So this is the next question, and here it says again, let A belongs to the set R, but this time A is greater than 1. Then we need to find out limit n tending to infinity of A to the power n. So this is very simple, but as always, I will now refresh and restart the poll, and all of you please try to attempt the poll. I see that some students are not responding in the poll. It is always a good habit to solve the question before we discuss the solution. That will give you some problem solving practice as well, and then it will make you think about the problem in different ways. And it's important to develop this practice of thinking instead of just looking at the solutions. And anyway, solutions will be discussed, so that is not an issue. Okay, and 4 options are there: 0, 1, A and infinity. Okay, let us now discuss the answer. So this is very simple, as we saw earlier. Over here we actually made use of this property earlier, so clearly limit n tending to infinity, a to the power n tends to infinity, so option D is the correct option because a is greater than 1. And we actually made use of this in the previous question, and it's just recalling that. So if you have a number which is bigger than 1 and you keep multiplying it with itself, then the number becomes bigger and bigger and bigger and it tends to infinity. On the other hand, if you have a number which is smaller than 1 and if you multiply it with itself, then it keeps becoming smaller and smaller and smaller and it tends to 0. For example, if you have 1 over 2, it's smaller than 1, and you multiply with itself, you get 1 over 4. You multiply another time, you get 1 over 8, which is smaller. Multiply another time, you get 1 over 16, and so on and so forth, and it keeps becoming smaller and smaller and it tends to 0. So these are the two limits, one for a being smaller than 1 and one for a being larger than 1, and in both the cases we are considering it as positive, so it's greater than 0. So that is for these two limits. Now we have a few more limits. So we can move. I hope there are no questions. This question 2 was almost similar to question 1. In fact, for question 1 we did solve question 2. So moving on to question number 3. Again, a belongs to R and 0 is less than a less than 1. Then we need to find out limit n tending to infinity for a to the power 1 by n this time. So notice that the exponent is 1 over n now. And once again, the poll has been restarted for all of you. So please take a few minutes to solve the question and answer the poll. Okay, let us now discuss the solution. So we have limit n tending to infinity a to the power 1 over n. This limit can be moved to the exponent. So this is basically a is a constant number. A will not change while we are taking n to infinity. What is going to change is this exponent. And again, 1 is a constant. It will not change. What will change is the denominator in the exponent. And now limit n tending to infinity of n itself will be infinity. So this will be a to the power 1 over infinity, and 1 over infinity is 0. So this is basically a to the power 0, which is equal to 1. So the correct option is option B, that is 1. Okay, now we can proceed to the next question. It is similar, just that uh, the range for the number a is different. Just like in the first two questions, first we had for a between 0 and 1, and then we looked at a greater than 1. Similarly here also we have now looked at a between 0 and 1, and next we have a greater than 1. So this is a question, question number 4. Let a belongs to R, a greater than 1, then limit n tending to infinity a to the power 1 by n equals what? We need to find out. So all of you please attempt this question. The poll has been relaunched. Okay, so coming to the solution for this question. This is again similar to the previous question and we will use the same strategy for solving. So since a is a constant, the limit will get transferred to the exponent, and again since 1 is a constant, it will go to the denominator, and limit n tending to infinity of n is infinity, and 1 over infinity is 0, so this is a to the power 0, which is once again 1. So same answer as previously. And you see why question number 1 and 2 the answers were different, but question number 3 and 4 the answers are same. Why this is happening is because a is a constant, so we are actually taking a constant and raising it to an exponent which is a function of n. So when you are having a constant and you are raising it to this particular form 1 over n and n tends to infinity, so no matter what this constant is, it can be greater than 1, it can be less than 1, but it needs to be positive, and no matter what this constant is, the limit in both these cases turns out to be the same, which is equal to 1. Whereas in the previous two questions, it mattered what the range for 1 is. Sorry, what the range for the constant a is, whether it is greater than 1 or less than 1. So you need to be careful about the constants and what kind of effect or role they are playing in the limits. Okay, moving to the next question, the fifth question. This is on sequences. Consider the sequences, the following sequences: an equals square root n plus 1 minus square root n, and bn is equal to square root n times, in brackets, square root n plus 1 minus square root n. And here n belongs to the set of natural numbers. Then these following options are there. We need to select which option is correct. Option A says both an and bn are convergent sequences. Option B states an is a convergent sequence but bn is a divergent sequence. Option C says an is a divergent sequence but bn is a convergent sequence. And option D, both an and bn are divergent sequences. So once again, take some time to answer this question in the poll. Okay, so let us now discuss the solution. So first let us look at the sequence an. So an is given as follows, and now we can rationalize it, and rationalization means multiplying and dividing by the by the quantity that I'm going to show you right now. So we have root n plus 1 minus root n. We will multiply and divide by root n plus 1 plus root n. That is rationalization. What this does is, now we have a minus, if you consider root n plus 1 as the quantity a, if you consider this as the quantity say a, and this as the quantity say b, then this is a minus b times a plus b format, which is a squared minus b squared. So a squared is n plus 1 minus b squared is n. And what we have is this n and this n cancels out. So this gives me 1 over square root n plus 1 plus square root n. Now clearly limit n tending to infinity of an is 0. Why? Because it this denominator goes to infinity. This is because limit n tending to infinity of square root n plus 1 plus square root n, this goes to infinity, and 1 over infinity is 0. So this implies that the sequence is convergent because the limit exists. Now let us look at the sequence bn. Actually I don't have space here, but what I will do is I will add a page. I will add a page over here. Yeah, this gives me some space. I forgot to add more space while preparing this document, but now I have added. So A is definitely convergent. So options C and D are eliminated, because in option C and D it is written that AN is divergent, but clearly we see AN is convergent. Now let us look at BN. BN is the following. And again we will do the process of rationalization. And this n in the numerator again cancels out. Now we have the limit. We need to look at this limit n tending to infinity of bn, which is limit n tending to infinity of root n over root n plus 1 plus root n. Now you see that this limit is of the infinity over infinity form. Why? Because limit n tending to infinity of root n is also infinity, and of the denominator root n plus 1 plus root n also is infinity. So this is of the infinity by infinity form, where both the numerator and denominator tend to infinity as n tends to infinity. So in such a situation, we will make use of a rule for finding limit, which is called L'Hopital's rule. It's written in this way, but it's pronounced as L'Hopital. So that rule we will make use of. And what that rule is states that when you have limits of the form 0 by 0 or infinity over infinity, then limit whatever you are taking it to, let's say limit x tends to y of alpha over beta, if this becomes 0 by 0 or infinity by infinity form, then that is the same as limit x tends to y, and you take the derivative of alpha. So you do d alpha over dx and d beta over dx. So this is the L'Hopital's rule, and we will make use of that rule over here. So what we have is limit n tending to infinity of root n over root n plus 1 plus n. We will now differentiate both the numerator and denominator separately. This is the same as limit n tending to infinity. Differentiating the numerator by n gives me 1 by 2 n to the power minus 1 by 2. Why? Because d by dx of x to the power y, say, is y times x to the power y minus 1. So that's for the numerator. Similarly, for the denominator, we have the following. Now 1 by 2 cancels out. So what we have is, and n to the power minus 1 by 2 is basically 1 over root n. Now let us take common denominator. Now this root n over here cancels with this root n over here. So we have the following. Now we see from here and here, we see that limit n tending to infinity of root n over root n plus 1 plus root n is same as the limit n tending to infinity of root n plus 1 and the same denominator. And let us call this limit as L. Okay, so what we have is, and let us now add these two. So what we have is, let us now consider, we are now considering adding these two. This is basically L plus L. So now we have we will add these two and take limit of the whole. So this is the same as the following. And clearly the numerator and denominator are the same, so they cancel out. So this implies that the limit L is 1 over 2. So basically it means limit n tending to infinity of the sequence Bn is 1 over 2. And once again, this implies that the sequence Bn is convergent because the limit exists. So that means both An and Bn are convergent sequences. What convergence means, that the limit of n tending to infinity for any sequence An should actually exist and be a finite number. Okay, so this solves question number 5 and we are halfway through. And since we are halfway through, I think let us take a short break of a few minutes before we move to the next half. In the next half, we now have functions, and in functions we have some of these true false type questions. Okay, someone is asking what is the difference between convergent and bounded. So convergent and bounded are basically two properties that a sequence can have. And convergent basically means that the limit n tending to infinity of the sequence An should exist. And bounded means that each of the element An should be less than some upper limit and greater than some lower limit. This is the condition for bounded and this is for convergent. For example, if you have a sequence, let's say sine n, then this sequence is bounded because sine can take values from -1 to +1, but it is not convergent because the limit n tending to infinity of sine n does not exist. It keeps oscillating between +1 and -1, so the limit as such does not exist. So this is an example of a bounded but not convergent. And earlier we saw some convergent sequences. and let us say a sequence which is just the following simple n. This is neither bounded nor convergent. And let us say we have a sequence which is e to the power minus n. Then this sequence is convergent but not bounded. The graph of e to the power minus n will look something like this. So it converges to 0, but it is not bounded. And we saw an identity in the lectures that if a sequence is monotonic, and if it is, let's say, monotonically increasing and is bounded, if it is monotonic and it has a bound, it is convergent. So like here you are seeing, so for example this e to the power so these three examples you just saw means bounded not convergent, neither bounded nor convergent, convergent but not bounded. Similarly, you can have convergent and bounded, which is the case for monotonic series. If it is monotonic and has a bound, then it is convergent. Okay, so we can proceed further. For any x belonging to R, define fx which also belongs to R to be satisfying x squared plus fx squared equals 1. State whether true or false that f is a function. This time I will launch a true false type poll. So please select either true or false. Okay, let us now discuss the solution. So we have x squared plus fx squared equals 1, which implies fx squared equals 1 minus x squared. This means that fx can be equal to plus or minus of square root 1 minus x squared. So this means that this is not a function. So the statement f is a function is actually false. And why this is not a function? Because what we have is, for one particular value of x, we can actually have two different values for fx. Two meaning multiple values for fx. So in a situation wherein a function, wherein basically some sort of a relation takes multiple values as the output for a given single input, then that particular relation is not a function. And if you actually were to look at a plot for this, this is actually the equation for a unit circle. So if this is x and this is f of x, so x squared plus fx squared equals 1 is actually the equation for a circle. And if you see that if you take some particular value of x, you can actually have two values for f of x. Now we can move ahead to the next question. Now we have a bunch of similar questions of different relations, and we need to see whether in each of the case whether f is a function or not. So moving to the next question, question number 7. For any x belonging to R, the set of real numbers, again we define fx belonging to R. This time it is satisfying x squared plus fx cubed equals 1. And here again we need to state whether it is true or false, whether f is a function. So once again I have relaunched the true false poll. Please take a few minutes to answer. Okay, so let us now look at the solution. And this is single valued. Why? Because we have this real, we are looking at real numbers. So for a single real valued x, the output is also real valued and single. And thus fx is a function. So this statement over here is true. If you want to see the plot, you can try to plot it in any programming language of your choice, or you can simply go to Wolfram Alpha, where if you just type plot the following function, it will give you the plot without you having to write any piece of code. Okay, so now next question. For any x belonging to R, define fx belonging to R. Now this time we have x squared plus fx to the power half equals 1. That means root fx plus x squared equals 1. And again we need to see whether f is a function or not. So the poll is restarted. Please try to solve this question and select the correct answer. So again we will look in the similar way as earlier. And clearly f is a function for reasons that we have just discussed above. That means for a single value of x, we get a single value of fx. Now we can move to the next question, the ninth question, which is also true false type, and to see whether this relation is a function or not. And this time we have x squared plus fx to the power 1 by 3 equals 1, and we need to see whether f is a function or not. So I will restart the true false poll, and please select the correct option. Okay, so we will look at the solution. So once again, f is a function, because if you have one particular value of fx, you will get one particular value of fx, so it is single valued. So f is indeed a function. Now we move to the last and the final question for this week, question number 10. The sequence sine to the power 5n over n squared, where n is greater than equal 1, is the following options are there: bounded and convergent, bounded but not convergent, unbounded and convergent, unbounded but not convergent. So this is similar to the previous question over here. We saw a sequence where we had to see whether they are bounded or whether they are convergent or not, and we did discuss about convergence and boundedness. So based on those concepts, please try to select the correct option. I will start the poll one last time for this session and take a few minutes to answer. Okay, so let us now discuss the solution. We have an equals sine to the power 5n over n squared. Now limit n tending to infinity of an is clearly 0 because sine n remains within minus 1 and plus 1. And then the denominator n squared goes to infinity, so 1 over infinity is 0. And so if sine n remains within minus 1 to plus 1, sine n to the power 5 also remains within minus 1 and plus 1. And since this limit exists, that's why it is convergent. And not only convergent, it is bounded also, because it is bounded between plus 1 and minus 1, between negative 1 and positive 1, again because of the property of a sine function. So the correct option is option A, bounded and convergent. So this completes week 3 for us. Again, we looked at 10 questions, some multiple choice, some true false, questions on limits of sequences, boundedness and convergence. We looked at these properties, and then we looked at functions. So that's all from my end for today. If you have any questions, you can ask them right now. And if not, then see you next week. So all of you can leave the meeting now. The lecture is over from my end. Okay, so bye everyone. See you next week.